Hello, my name is Satvik, and my group consists of me, Josh, Carter, and Akil, and we all go to Patapsco Middle School. Josh, Carter, and I were responsible for the coding of the circuit board and programming it to calculate the respiration rate. In addition, I found a location for the circuit board on neonatally that would negate any tilt of the circuit board. If the circuit board was tilted, it would give us inaccurate data. I also provided our group with the necessary materials to complete our work every day. Furthermore, Josh was responsible for designing the swaddle, as he sewed a little pouch in the desired location on the swaddle that we were going to use on neonatally. Also, Carter was responsible for planning out what we were going to do each class, and he kept us on task. Lastly, Akil was responsible for analyzing and interpreting the graphs, as he made sure they were accurate. He also helped problem solve, as he came up with different solutions to help us move forward within the project.
Our team designed a device using the Adafruit Circuit Playground Express, where we coded it to detect the respiratory rate of a newborn baby. We sewed this device into a swaddle so that it can accurately measure the respiratory rate. The process that our team used to build our device was we first researched the circuit board. We also reviewed the criteria, constraints, and goal of the device. After this, we made a diagram of the device on the computer. Once we finished our plan, we started coding the circuit board. Once we finished coding, we sewed it into a swaddle. We only had one iteration of design, but throughout the coding of the circuit board, we had to change it until we figured out a working code. After we would change the code, we would test it on neonatally and would change it again if it didn't work. When we faced obstacles, we worked as a group to figure out possible solutions. The expenses related to our device is we used the Adafruit Circuit Playground Express, which costed $25. We also used a swaddle that was donated but costed $5. This makes the total cost of the device $30.
To implement our design, we will attach the Adafruit circuit board to the swaddle and put it on neonatally. The circuit board will be able to detect the baby's breathing rate and will alert doctors if it gets dangerously low. However, there is room for human error with our design that can be easily fixed. If doctors move the baby, there is a possibility that the circuit board could fall off without the doctors noticing. Also, if the baby is positioned in a certain way, the respiration rate may not be tracked. These issues can be easily countered if we sew the circuit board to the swaddle.
In this device, we used MakeCode from Microsoft in order to code the actual circuit board. What we did was we applied the circuit board toward the child, in which its up and down movement would be plotted on a graph and used as an output for data. We used the plot axis Z, also known as the force of gravity, on the board to calculate its up and down movement, which will later give data from a range starting from -1023 upward. For the following code, we used logic from the Microsoft MakeCode app. We used a console log value to calculate the circuit board's movement using the axis Z, known as the force of gravity. Now, when downloading this device, we see that the board will maintain a red light with a siren because the breath rate is not safe. However, if you end up moving it, the colors will evidently alternate, showing that its breath rate is at safe terms. Now, if you go to the show console of the device, we can find the baby's breath movement, which is then later put into an output of data. We can use this data to calculate the actual BPM of the child through this proper graph. And with this graph, we can put on a timer for 60 seconds, calculating the amount of peak moments, which can be later counted as one breath.